Okay, so next we're going to introduce the concept of filters on RDDs, a way to strip out information we don't care about. And we'll do this in the context of another real example. We have some real weather data from the year 1800, and we're going to find out the minimum temperature observed for each weather station. So let's go through the concepts and walk through the code and get started. Okay, let's introduce the concept of filtering RDDs next. It's just a way to strip down an RDD into the information you care about and create a smaller RDD from it. It's pretty straightforward, but let's do it in the context of a real example. So we have some weather data from the year 1800 that I've gotten off the internet. And what we're going to do is try to figure out the minimum temperature observed at various weather stations in the year 1800. While we're at it, we'll also use the concept of key value RDDs as well as part of this exercise, so we'll reinforce that from the previous lectures as well. So filter is just another function you can call on a mapper. It transforms it by removing information, potentially, that you don't care about. And in our example, our raw weather data actually includes things like minimum temperatures observed and maximum temperatures for every day, and also the amount of precipitation observed for every day. But all we care about for the problem we're trying to solve is the minimum temperature observed at a given station for the year. So we need to apply a filter that just looks for weather data types of Tmin and allows those to pass through to our new RDD that we're calling min temps, but everything else, like Tmax entries or precipitation entries, will just get discarded. So we can take our parsed lines RDD, filter out anything that's not a Tmin entry, and construct a new min temps RDD out of it. So basically, filter takes a function that returns a Boolean value, true or false. If it comes back true, then that value is passed on to your new RDD. If not, it just gets discarded. It's just that simple. That's all there is to it. Another common example of using filter might be if you're processing log data from a website and you only care about analyzing certain types of events or certain types of transactions or maybe certain kinds of error codes. Filter is a way to strip out all the other stuff in the log that you don't need and then have a much smaller RDD that you can then work on more quickly and more efficiently. So let's take a look at our actual source data here that we're working with. This is real weather data from the year 1800. And the format of our data is a comma-separated list of values on each line, where each line indicates a given observation at a given day at a given weather station. And the format here is weather station ID. If I remember right, this corresponds to Paris and the Prague, followed by the date, and that's in year, month, day format, so 1800, January 1st in this example. And then the observation type, so here that's Tmax, so the maximum temperature observed on January 1st, 1800 for that weather station was -75, and that's actually in tenths of a degree Celsius, so that means -7.5 degrees Celsius was the maximum temperature observed on January 1st, 1800, and I believe that's Paris. Pretty cold day. And then we have a bunch of extra fields that are unused in this data set, and we can just discard those. So what we care about are the Tmin entries, because we're trying to figure out the minimum temperature observed for each weather station for the entire year. So again, for this line here, we'd have the weather station ID, the date. Min temperature is the type of observation. -14.8 degrees Celsius was the coldest temperature observed, the minimum temperature on that date at that weather station. First thing we need to do is load that data up into an RDD. So we'll call text file on our Spark context and load every line of that input into a lines RDD. And we'll take that RDD that we called lines and apply our parseLine mapper function to it to create a parseLines RDD. So what that's going to do is split out our fields by commas, and then we'll extract the station ID text field, the entry type, which is going to be Tmin, Tmax, or precip, and we will then convert the temperature to degrees Fahrenheit because I'm a Fahrenheit kind of guy. I live in the United States. First thing we're going to do is extract the actual field, the numerical field of the temperature from the line. We're going to tell Python that is a floating point numerical value so it can actually perform arithmetic operations on it. I will first convert it from tenths of a degree Celsius to degrees Celsius, and finally apply this little bit of math here to convert from Celsius to Fahrenheit. And what I'm going to return is this composite value, this list that consists of the station ID, the entry type, Tmin or precip, and the value of precip, the actual temperature observed. Okay, so basically I've parsed out my input data into something a little bit more structured, where the new values are these composite values that consist of a station ID, the entry type, and the temperature. Okay, so that's what my new RDD contains. One of these for every observation seen for every weather station ID on every day of the year. All right, now I'm going to call a filter on it. Now you remember that we stored the entry type in field number 1. We start counting at 0, so field 0 is the station ID, 1 is the entry type, 2 is the temperature. So if we see Tmin in field number 1 of our value, we are going to let that pass. Otherwise, we will discard it. So what we're going to end up with here is a new RDD called min temps that contains only Tmin entry types, observations. And the actual format of the RDD will be the same. We're still going to have station ID, entry type, and temperature composite values here, lists, if you will. But we're only going to have entry types that contain Tmin at this point. Okay? So, given that everything in our RDD consists of Tmin, we don't really need that Tmin anymore, so we can strip those out now. And we're going to apply a new map to our RDD that does exactly that. So we're just going to transform every composite value to a new one that just consists of 2 values, which is the station ID and the temperature. And at this point, we have a key value pair in our new station temps RDD. Since we're down to just 2 values, our key is the station ID and the value is the temperature observed, which again at this point is in Fahrenheit. So at this point, for every day of the year, we have a minimum temperature observation for a given station ID. Finally, since we want to find the minimum temperature for the entire year for every station, we can call reduce by key to do that. So that's going to aggregate together every minimum temperature observed for every weather station ID. And our lambda function will determine how we do that aggregation. So we're saying that for whenever we try to combine 2 observations together for minimum temperature for a given station, we're going to call the min function to actually only take the minimum value between those 2. And as we keep feeding more and more observations for each weather station in there, only the smallest value, the minimum value, will survive in the end. So at the end, we have our final result. We have a min temps RDD that's going to be reduced by key. So all we have is 1 entry for every weather station ID that contains the minimum temperature observed throughout the entire year for each weather station. Finally, we need to call the collect action to actually kick it all off and make Spark go do something and collect the results into a regular Python list called results. And we will just iterate through that and print them out. And we'll do a little bit of fancy formatting here. If you're new to Python, this is just saying that we're going to print the weather station identifier string followed by a tab character and then do some formatting to ensure that the actual temperature is truncated to 2 decimal places to the right of the decimal point. And we'll stick the letter F at the end just to indicate that the result is in Fahrenheit and not Celsius. So let's go look at the code and actually run this thing and see what it does. All right, so that's how we're going to use filters to actually boil down the minimum temperature observed for each weather station, and we'll use the key values to do that and reduce by key to actually boil down the final results just like before. So let's dive into the code. It's going to make a little bit more sense when you see it all together. So let's take a closer look and actually run it and see what the answer is.